Is this processing control? Well, it looks stable, right? It's not moving up or moving down. But of course, we don't know really until we have the control limits. So let's put in place what we've learned and put in the control limits. Here they are. Oh, easy. Look at, there's even quite a bit of white space between the control limits and the actual data. So clearly in control. However, it turns out this is a simulated example. And sneakily, after observation 20, so roughly here, I have added 0.2 standard deviation to the mean each time for each observation. So really, there is a mean shift. So the first 20 observations are as before, and then it shifts up. But because the mean shift is very small, it's not detectable using this control chart. So what do? We have to think of another control chart. And specifically, so far, we've only looked at a chart that is based on a single observation or based on a single subgroup, the current day. What we do now is we look at charts that incorporate both the current data or the current day and past data. And the chart today is the CUSUM chart, or cumulative sum. We again assume we have a normal distribution here with mean mu and standard deviation sigma. And then we can measure departures from the mean by subtracting off the mean for each observations and just summing it up. So this is the current observations, and I'm including all of those in the past. And each time I'm subtracting the mean. And if there's a mean shift, then it's gonna show up by getting this additional 0.2, 0.2, 0.2, and so forth. So it's gonna accumulate. All right, so let's see an example here, just to fix ideas. We have from the first 20 observations, mu hat equals 6. So I have the mu hat here. I have the actual observed values here. And then I get the difference. 6.9 minus 6 is 0.9. So cumulatively still 0.9 because we don't have any prior data. Here the difference is minus 0.3. Minus 0.3 plus 0.9 is 0.6. Again, another minus 0.3 plus 0.6 is 0.3, and so forth. For you, I have one question here. What is the value in this field? I will leave you to ponder that question, and I'm moving on. Okay, here I have the Schuhart's chart that we already saw. And here we have the corresponding CUSUM chart. So notice we're starting here at 0. And for the first 20 observations, it wiggles around a bit, and then it takes off. It really takes off, because on average, we're adding 0.2 standard deviations each time, right? So it really takes off, indicating that a mean shift occurred here. Okay, but is it really out of control? And for that, we need control limits, right? So the mean shift is easily detectable on the CUSUM chart, but was hard on the Schuhart chart. Now, with the control limits, it's not as easy as before. I have simulated here 5 runs. So we have 5 run charts here that are in control without a mean shift. So what you see here is what you expect to see. This is normal behavior. This is in control. And what you also see is that, well, the CUSUM is either strongly decreasing or increasing or something in between. And what you can maybe guess from this is that any control limits that are to be constructed are actually not constant. Right? These are all in control processes. They should not be outside of a control limit. So the control limits here would be increasing probably linearly and decreasing linearly. That makes it a bit more awkward for charting because you have to figure out what the control limit exactly should be. And instead, we will look at a different technique. Well, it's a variation on this technique, the adjusted CUSUM, in the next segment. But this is it for this segment.